Okay, so now we'll go to an Excel sheet again to demonstrate the counting rules topic and using some of the functions of Excel. So let me share my screen with you. Okay, and go to an empty sheet, which I will use to demonstrate these functions. So the first rule we learned was the multiplication. So we had this example of rolling a die 3 times, and how many different ways can this be done? So basically, if you actually have 6 possible outcomes and you're doing this 3 times, so we could use the power function, okay, and take this number to a certain power, and basically 216 different ways of doing this, okay, using the multiplication rule. All right. So then we looked into the factorial, okay, and we had this problem whereby we wanted to organize 5 books in a bookshelf with 5 positions. So then we can use the fact function, which has another version, double fact. Okay, so if I say fact 5, I will have 120, and that will basically be 5 times 4 times 3 times 2 times 1. Now the double fact, let's just do that again. Fact double, and if it's 5, it gives us 15. It's going to be basically 5, and we're jumping one even number, 5 times 3 times 1, and that's going to be basically just 15. And if there's an even number, again, you're jumping the odd numbers when you're calculating. So this is the factorial. Okay, number of different ways I can organize n items in n places, and order is considered to be important. So then we looked into permutations. Okay, so suppose now I have 5 books, but I have 3 places. So then I will get into 5, which is n, and number of places I'm going to place these books, and I have 60 possible ways. And how this is calculated is basically I multiply 5 with a number less than itself times 4 times 3, and I go to as many as the number of places I have. Okay, so that will be basically equal to 60. So this is permutation, factorial, double factorial, and the power rule. And as a final rule, let's look at the combinations. So what if the order is not important now? So I just want to pick 3 books from the 5 to read. So then I can use the combin function, which is right here. And I would say 5 and 3, and this is 10. So basically how this is calculated is I would calculate 5 times 4 times 3, and I would divide this by the number of ways the 3 items can be organized, can be ordered within themselves, which would be 3 times 2 times 1. Okay, and if that is the case, I find 10 possible ways. All right, so those are combinations, permutations, factorial, and the multiplication rule that we just discussed today. So, and as you remember, I also showed you this Pascal triangle, which includes all the combinations, and it can be started from 1 and then 1 and 1, and by adding the elements before the row in the triangle, we can actually form this Pascal triangle. So now let me actually try to show that maybe with Excel, how we can form it. And I'll do it with 12 and going to 12. And it has to start with 1, choosing 0 elements from 0 elements. Then it goes 1 and 1. And this triangle will be a bit different, but that's because I'm doing it in Excel. So this is choosing 0 from 1 and choosing 1 from 1. So then it will be, I can now write a formula, adding the two elements on top. Okay, so, and I can drag this to the rest, and actually I can form my triangle. And it's gonna look better as I move to bigger numbers. So I want to move up to 12. And the formula just carries on. So okay, that's 10, that's 11, and that's 12. So basically you see here 66 is formed by adding 55 and 11, and you could represent this better by organizing them in a symmetrical fashion, but since I'm doing it in Excel, we have to live with this for the moment. So what this number here is giving me is basically it's giving me combin 12 and 1. Okay, and 66 is basically combin 12 and 2. So this last row gives me all the combinations I can take from 12 items, and it's symmetrical. You can see, so 12, choosing 1 from 12 is the same thing as choosing 11 from 12. 2 from 12 is the same thing as choosing 10 from 12. So if you change this into 10, you're going to get the same number. So this triangle is actually symmetric. So that was an interesting demonstration I made here using Excel to create the Pascal triangle and also using permutation, combination, and factorial functions.